So welcome to another video lecture of OpenStax Astronomy. Here we'll be covering Chapter 6, Astronomical Instruments. And we're going to do just a quick brief overview here, really talk about just mainly some of the benefits of using space telescopes. So we're going to bundle up kind of 6.1 and 6.4 here for this short video here. Here we see two pre-telescope observatories. So we've been using observatories to understand the heavens for a long time. Machu Picchu here in the 15th century, here in Stonehenge, a prehistoric site about 3000 to 2000 BC in England. And so using instruments is something that's extremely beneficial to us. The telescope was a tool that really helped us push modern astronomy forward to get a lot of observations. So how do telescopes help us learn about the universe? Well, telescopes collect more light than our eye. So the collection area, you have larger mirrors, so you could collect more light, more photons. Telescopes can also see more detail than our eyes, so angular resolution, a lot sharper than just our eyes. We could only see so far. We could have telescopes that see extremely far, like the Deep Space Hubble telescope was able to see to the edge of the observable universe. And also telescope instruments can detect light that is invisible to our eye. So not just looking at visible light, but at other parts of the electromagnetic spectrum. Here we have an image of Orion's nebula here, and we can actually see it in three different wavelengths. So visible light, the first image there, and we see that it's a bit faint. We don't see too much characteristics. We kind of see some bright features there in the center, but fairly dim around. Now the same image in X-rays now, we're able to see objects that were a bit fainter. We're able to kind of detect them. And then in infrared, we could also see the gases around there in that Orion's nebula. And so looking at it through different wavelengths, we're able to detect more. And so we typically put these collages together, and that's how we see some of these nice, impressive astronomical images. We're looking at different wavelengths, but then we add not some false color, but we adjust the color spectrum to our eyes. So if we're looking at something in infrared, we can't actually see that. So this image on the red here where we're detecting more heat, notice that we could actually see through that plastic bag. So if there was dust there, we'll be able to see through it. And so we can't really see infrared, so we attach coloration to it, so perhaps red, and that is a false color, but it's so we could actually detect that with our eyes. One issue we have with ground-based telescopes is turbulence in the atmosphere. So as light goes through the atmosphere, it tends to kind of twinkle back and forth, and we get images that are not that sharp. So adaptive optics helps us to correct for that when we use mirrors and we use some of the instruments. So things are blurry, and we correct for that. This leads us to some of the benefits of why we put telescopes into space. And it's not because they're closer to the stars. I mean, it's a little closer, but it really doesn't make too much of a difference. The three main reasons are, first is light pollution. We have a lot of pollution here. If you go outside at night, look at the stars, we don't see too many. But if you've ever been out in the desert, driving out to Vegas or so, you'll see that there are hundreds of stars out in the night sky. So light pollution is one main issue. If we're outside of the atmosphere, we're not going to have to worry about that. Turbulence, as we talked about, adaptive optics helps us out with that here on ground-based telescopes. But if we're in space, we don't have to compensate for that. We're not going to get that blurriness that we see. And so, for example, the Hubble Space Telescope was able to get some clear images there. We don't get that twinkling. And you could see this. Look up at a star, and you'll see that it kind of twinkles a little bit, right? As you get that light, it's not perfect. You could kind of see it just twinkling a little bit, and that's that light going through the atmosphere. And the third reason is our atmosphere protects us from some of these hazardous wavelengths. And so we really only see visible and a few others. Radio will get and infrared slightly. But we don't see a lot of the other parts of the spectrum there. So putting those telescopes up in space helps us out with that.